This question asks, consider the tertiary amine provided. Which of the following starting materials could be used to synthesize this amine using reductive amination? So what is reductive amination? That's kind of one of the big parts of this question, is figuring that out. It's a way to make amines. We typically did that using some sort of aldehyde or ketone, reacting it with an amine, ammonia, a primary amine, a secondary amine, and then sodium cyanoborohydride. So we kind of draw what that scheme looks like. So this is kind of the general idea right here. I'm going to just very generally draw an example. We use NH3 and H+, and then the sodium cyanoborohydride. And kind of the main result of this is that we made an imine intermediate. And then that would be attacked by our sodium cyanoborohydride to make an amine. So in this case, we would have made this molecule as our product. And so, you know, let's apply that now to this kind of molecule that has 2 rings in it. Okay, so in this instance, we have a tertiary amine. So that tertiary amine kind of has 3 places where we formed carbon to nitrogen bonds. And those are kind of the key places you want to look at when you're thinking about kind of working backwards from a reductive amination. Because in reductive amination, we're essentially making a new carbon to nitrogen bond. So like, for example, this is the new bond from my generic example. Oops, let me add in the hydrogen real fast before I get too far. There's a hydrogen here and a hydrogen there. Because my starting material had a hydrogen, didn't want to forget that. So when we look at the tertiary amine that we're kind of focusing on for this question, we can break the bond in any one of those 3 locations and work our way backwards to some kind of amine, and then either an aldehyde or ketone that would allow us to make it. So the question here is, of the answer choices that we have, which ones can make the specific compound that's on the slide? So let's take a look at the first molecule. In this case, we would be forming let's see, 1, 2, 3, 4, 5 sized ring on the right-hand side, okay, because our amine is going to react with that aldehyde that we have there. And so that could work because you have the 6-membered ring right here, and then we'd be forming a 5-membered ring. And that's exactly what we have up here in our starting material. Next, let's think about molecule number 2. Molecule number 2 has the 6-membered ring, but if we number this way, we do get a 5-membered ring, but no, there's a methyl group hanging off here. And so that would have to have some kind of like a methyl on the starting material, which we don't see. There aren't any substituents. So we can kind of cross 2 off because it's not going to have that extra methyl present. Molecule 3 has a 5-membered ring on one side, and then a 1, 2, 3, 4, 5, 6 carbon chains that we can form. So in this case, that will allow us to form the left side of this bicyclic compound. So both 1 and 3 can make this molecule via reductive amination. And so our answer choice is C.